Hey there, science fans! Today, we're diving into the incredible world of nuclear power. Nuclear power plants are like giant energy factories, and they play a crucial role in providing electricity to many parts of our world. Imagine a world with fewer blackouts, less reliance on fossil fuels, and more clean energy sources. That's where nuclear power comes in. But how do these amazing plants actually work? Well, it all starts with a tiny but mighty process called nuclear fission. Don't worry, we'll break it down in a way that's easy to understand. Nuclear power plants are complex but fascinating. Understanding how they work allows us to make informed decisions about our energy future. So let's get started on this electrifying journey. At the core of every nuclear power plant is the reactor. Think of it as the plant's beating heart, where all the action happens. Inside the reactor, you'll find fuel rods typically containing uranium. Uranium is a special element because its atoms can be split apart, releasing an incredible amount of energy in the process. These uranium fuel rods are carefully positioned within the reactor core, surrounded by a substance called a moderator. The moderator helps slow down the neutrons released during fission, making the chain reaction more controlled and efficient. Now, let's talk about fission. This process is the real star of the show. When an atom of uranium is struck by a neutron, it splits into two smaller atoms, releasing energy in the form of heat and more neutrons. These newly released neutrons then go on to strike other uranium atoms, creating a chain reaction. Imagine a domino effect, where one domino knocking over another leads to a whole chain of dominoes falling. That's kind of like what happens during nuclear fission, except with atoms and a whole lot of energy. This heat generated from fission is what ultimately allows us to produce electricity. Section 4, From Heat to Electricity, the Role of Steam and Turbines. The intense heat generated within the reactor is used to boil water, producing steam. This steam is then channeled through pipes to spin giant turbines. Think of these turbines like giant windmills, but instead of wind, they're powered by steam. As the turbines spin, they turn a generator, which is a machine that converts mechanical energy into electrical energy. It's a bit like how a bicycle dynamo generates electricity when you pedal. Now, the electricity is ready to be sent out through power lines and into our homes, schools, and businesses. Section 5. Keeping things safe, control rods and moderators. Safety is paramount in a nuclear power plant. Remember those control rods we mentioned earlier? They play a vital role in keeping the nuclear reaction in check. These rods, often made of materials like boron or cadmium, are excellent at absorbing neutrons. By raising or lowering the control rods within the reactor core, operators can carefully control the rate of the nuclear reaction, ensuring it doesn't get too hot. The moderator also helps to regulate the chain reaction by slowing down the neutrons to optimal speeds for fission. Section 6. Cooling down. The importance of cooling towers. After the steam has done its job spinning the turbines, it needs to be cooled down and converted back into water. This is where cooling towers come in. These iconic structures, often seen in images of nuclear power plants, play a crucial role in the process. Inside the cooling towers, the steam is condensed back into water using air. The distinctive curved shape of the towers helps to enhance airflow and cooling efficiency. The cooled water can then be reused in the plant, making the process very water efficient. Section 7. Nuclear power benefits and challenges. Nuclear power offers significant benefits as a low-carbon energy source. It helps reduce greenhouse gas emissions, contributing to a cleaner environment. Nuclear power plants also boast high reliability and can generate a lot of electricity from a relatively small amount of fuel. However, it's important to acknowledge the challenges associated with nuclear power. Safety remains a top priority, and stringent measures are in place to prevent accidents. The handling and disposal of radioactive waste also require careful management to protect human health and the environment. So there you have it. Nuclear power is a complex but fascinating way to generate electricity. It plays a crucial role in our current energy mix, and understanding how it works is essential as we explore sustainable energy solutions for the future. Remember, knowledge is power.